Hey guys, I'm covering a very popular problem this week, and it's about finding the largest rectangle inside of a histogram. So it may seem complicated at first, but I go through my entire thought process and you'll see at the end how simple the solution is. So also let me know in the comment section below what you think of the solution and if you have your own solutions. So let's dive right into it. So we are given a histogram that looks something like this, and we have to find the maximum rectangular area within it.
Correct.
Okay, so let's look at this example. We have an array that you translated into a histogram over here, right?
Mm-hmm.
So just a few questions on it. All of these numbers over here, they correspond to the heights of these bars.
Yeah.
And what about the width?
You can consider each of them with the unit width.
Okay, so
unit.
like constant, right?
Yeah,
Unit
they're all
1.
same.
Okay, so let's say the widths are just 1 unit for all of these. So let's see how I would do it. The first thing that comes to mind is that I would iterate through this entire array.
Mm-hmm.
For each index, I would see that what are its neighbors.
Mm-hmm.
So let me just give you an example. Let's say I am at 3, right? I'm iterating the array, and I'm done with the prior indices. I'm at 3 right now. And then for this index, I'll say, okay, what are the values to my right?
Mm-hmm.
And I will go all the way till the next value is less than me, right? So let's say over here, I stop right there, right?
Yeah.
And I'll do the same thing. What are the values to my left? And I'll go all the way till the next value is less than me. So I'll stop right there. So in this case,
So
for
T is equal to your current index. So will you include that bar or not?
I'll include this. Yes. So this is the entire width that I'll have, right?
I'm talking about 3, the bar that you left.
This 3?
The
This bar?
left one.
This one.
Yeah.
Oh yes, you're right. It's the same height, so I'll include that as well.
Mm-hmm.
So basically, I have a width that is 1, 2, 3, 4, and 5 units,
Mm-hmm.
and the height would be 3. So 3 times 5 is 15. So that would be the max area that this particular rectangle would make, right? So I'll do the same thing for all of these, and then I'll keep updating the global max,
Okay.
as I'm going through it. But obviously that method will be O of n squared time complexity. So perhaps there's a better way to do it. So let's see how we can do it in a better fashion. Now let's say I am iterating through this histogram.
Mm-hmm.
I start from index 1. So what my goal is that I don't want to iterate through the entire array for every single index.
Mm-hmm.
I just want to iterate through it once,
Okay.
and perhaps store some values that I would deem are necessary.
Mm-hmm.
So let's say I'm starting with the first value, or with the first index, and I say that, okay, the next index, or the value of the next index, is greater than or equal to itself. If it is, then I know that I'll be able to expand my rectangle into it,
Yeah.
right? So I'll just keep going till the next value is greater than or equal to myself.
Okay.
So, and then throughout the time, let me also record or keep a log, because I just want to iterate through this array once, right? I don't want to go back.
Yeah.
So let me just keep a log of all of the ones that I've already visited. So I'll say, okay, index 0, as I have duplicates over here, it doesn't really make sense for me to log values. So I'll log the indices. So I'll say, okay, I visited index 0. Now I'll just keep doing the same thing. I'll climb this ladder as long as the next value, or the next height of the bar, is equal to or greater than the current height of the bar.
Mm-hmm.
So I'll have 0, 1, 2, 3, 4. So 0, 1, 2, 3, and 4, right? And then when I go to 5, I know that the height drops. So I stop right there, because obviously 5 can't include the 3 rectangle in its area, because this thing is all blank.
Basically, the fifth bar can't go any further to its right.
Right, the 5th bar can't go any further right.
Mm-hmm.
Yes, exactly. So let me just erase this, make it cleaner. Okay, so we are over here, right? Let's say we stop right there, right?
Mm-hmm.
And I have this these are the bars that we already encountered on the way. So when we stop right here, perhaps this is a good opportunity for us to say, okay, let me just calculate the area that this bar would make.
Yeah.
So the way we can do it is we can say, okay, let me start from this point.
Yeah.
And let me go to the left 1 unit so that I can cover myself,
Yeah.
right? And I know that the bar besides me to the left, which is this one, its height is less than myself, or it may even be equal to myself, you know? So perhaps in the first iteration, you know, let's just assume that the bar's height is less than myself. If that's the case, I'll say, okay, let me just go 1 unit. So this width is 1 and the height is 5, and my max right now, let me just keep a log over here. The max area is 5. Now, let's say, so I don't want to compute anything twice, right?
Yeah.
So I computed the area that this rectangle can make,
This bar.
or this bar can make, and I will take that out of my array, you know, just to say that I'm done with it. Now I'll say, okay, let me move further. So this bar is done, right? Let me just put a cross over there. That bar is done. Now I move further, but I still encounter 3 that is less than now whatever bar is at the end, which is at index 3, which is a height 4. So even 4 can't extend itself. So I apply the same logic as we are over here. You know, this is the anchor point, and we know that all of the bars to the right of 4 inside of this array are the height of them is equal to or greater than 4, right?
Yeah.
So they can be included in its area. So that prompts that, okay, let's start from here and let's go till how far can we go? I start over here and then I want to go till whatever is before me, right? I don't want to, because this is my point, so I want to go till whatever bar is before me and get that width, and then multiply it with my height, and I have the area that this bar can make, right?
Yeah.
So let's do that. So this is 4 times 2, which is 8. So now this is a new maximum, so I update that to 8, right? So now I have the area of this rectangle, basically, right?
Yeah.
And I'm done with this guy. Now I go further. The next one in line that we haven't computed yet, so we're done with these 2. We don't care about those anymore. So the next one in line that we haven't computed yet is 3. So as I move forward in my iteration, I need to make sure that the next one is 3 or less than 3. So this one is 3, so it's okay. You know, I can keep stepping up, basically, in our metaphor. I can keep climbing the ladder.
Or you can keep including them to your
in my array.
rectangle.
Yes. So I can keep yeah, exactly. So I can include this bar into this bar's rectangle,
Yeah.
right? So let me just add that over here. And the same thing with the other 3.
You
So
will
actually
need the
this is the
index.
index. Yes,
Yeah.
is the index. So 0, 1, 2, 3, 4, 5. 5, and then I'll include 6 as well. Now when I encounter the next one, so now I'm done with these 2 indices, right? Now I'm over here. I see that it's going back down.
Yeah.
This bar can't include this one in its area.
Yeah.
So I'll anchor myself right there. Okay, I want to stop there. And then we'll do exactly the same thing. We'll say that, okay, now let's take care of this guy first and see what's the max area that it can make. The max area it can make is, in this case, starting from the anchor, going all the way till whatever is before it, right? Because we know that we want to stop at whatever is before it, because that can be less than itself.
Yeah.
So we start over here. So this is what? 3 times 1, 3. It's not greater than max, so we ignore it, right? At the same time, I take this out.
Yeah.
Now I'm over here. Same thing. I can't iterate any further, so I need to compute the area of this bar, or the rectangle that this bar can make. So same thing. My anchor is still over here.
Yeah.
And I say, okay, let me go all the way till the rectangle that was before me. In this case, it's this one. So let me just take these 2
Bar
out.
before.
Or the bar, yes, the bar that was before me. So in this case, it's the one at index 2, which makes total sense, right? Because these two are greater than 3.
Yeah.
So obviously this guy will be able to extend into them. But as far as our logic goes over here, these are like not even there,
Yeah.
right? We're done with them.
It
Actually,
makes sense because like like everything in your record is still lower than what you are viewing right now.
right, exactly. So everything to the left in my record is still less than or equal to
Yeah.
the height of my current one. So then I say, okay, let me start here and let me extend this to all the way there, right? Right before my previous element. So then I'm talking about this rectangle here.
Yeah.
So this is what? 1, 2, 3, 4, 4 times 3, which is 12. So I'll update my max,
Yeah.
right? So then I'm done with this guy.
Yeah.
And I am at 2 now. So obviously I can include this one now, right? Because I can...
but the value at index 2 is
Oh, sorry, it's 3. Yes, this is not the value. So I can't include 2 yet. This is still 3. So I do the same thing. I start at the anchor and I go all the way till the index 1, right? And I say, okay, what is the area over here? So this is 1, 2, 3, 4, 5. 5 times 3 is 18. 5 times 3 is 15. So the max will be 15 now, right?
Yeah.
And I'm done with this guy. By the way, as I'm going through this, I'm only concerned with the last index of this array. So probably should have used a stack. So in the implementation, I'll actually use a stack and not an array.
Yeah, makes sense.
So so this guy's done, right? So now I'm looking at this one. So obviously I can include this because this can encompass this in its rectangle. So I'll say, okay, 6 and 7. So these two are done, right? So let me just erase them. And this one's done as well. Okay, so now I'm done actually. Now I don't have any more, right? I can't iterate further. So I stop right there and then I have some stuff left in the array, or now it's a stack, let's say. Let me just make it a stack, right? So I have what? 0, 1, and 7. So I say
the bars that you haven't calculated the rectangle for.
Right, so these are the bars that I have yet to calculate rectangles for, right?
Yeah,
So I start at index 7, which is this bar. And I say, okay, let me calculate the rectangle for that one.
Yeah.
I say, okay, in order for me to do so, I'll need to anchor my my right point to the index after me, right?
Yeah.
It'll probably be at the length. And I need to go all the way till this one. So I'll need to stop right there, right?
Yeah.
So I'll have 1, 2, 3, 4, 5, 6, and 7.
6.
1, 2, 3, 4, 5, 6. Yes, I'll stop right there. So I'll have 6. 6 times 2 is 12. It's still not greater than 15.
Yep.
So it's okay. But I'm done with this, right? Now, I have 1 left. So the number at index 1. So I do the same thing. I calculate its rectangle. So it's basically from here, still the anchor point remains the same, all the way till there. So this is what? 6 times 2.
7
Or 7 times 2. 1, 2, 3, 4, 5, 6, 7. 7 times 2, that is 14. Still less than 15.
Yeah.
Same thing over here. This will be what?
To the length.
Yeah, 1 times 8, which is 8. So it looks like the max is going to be 15.
Yeah.
So it looks like this implementation works. And also it's just linear time complexity because we're just iterating to this array once. And we have stack on the side, but we're not really going through all of the elements at any given point in time.
Yeah.
So if you don't mind, let me transform this logic into actual code.
Yeah, sure.
Okay, so let me erase this as well. All right, so let's say I have a function. Let me actually erase this as well. let's call it max area.
Mm-hmm.
And let's say it takes in a histogram. So the first thing I would want to instantiate is a stack, right?
Yeah.
So I'll say stack, and obviously this is pseudocode. Stack equals new stack. And then at the same time, I want a global maximum to keep track. So I'll say max area. Actually, I already call it max area. So let me just call it max. Our function is max area, right?
Yeah.
Max equals 0 initially.
Mm-hmm.
And to iterate through this array, as we are anchoring at certain points, I would use a while loop because I want full control over when I'm incrementing the index. I don't want it to be automated. So I'll say initial index equals 0, and then we'll go into the while loop. So I'll basically say while I is less than hist dot length. We should do this. Now what should we do? Well, if the stack is empty, then we should push whatever is the index. So we shouldn't actually push the values, just like I did over here. We should push the indices. So I'll say if stack dot is empty is true. So is there any other condition when we would push it? We would also push the index when it is greater than whatever was indexed before it, right? So I would say, or if stack dot, let's see, how would we, so if we would say if stack dot peak, right? So the current index that we have at the top of the stack, it should be less than or equal to. So it's less than or equal to the value at hist I, right?
Yeah.
So if this is the case, then we add the element or the index into our stack. Let's say stack dot push I, right? And we will also say I++ then.
Yeah.
So this concludes this if statement. But if this is not the case, then as we saw over there, what we do is we start computing the area.
Yeah.
And also we don't just compute the area, but we pop it out of the stack, right? So let's do that. Else we say, let's call it current. So at this point, the bar that we are at will be the maximum of all of the bars that we have encountered, or of all of the bars that are in the stack, right?
Yeah.
So let's say cur max. Let's call it cur max, or cur highest.
Cur max is simpler.
Cur max. Okay. Let's say cur max equals stack dot pop. So now I would have popped it. So I know what its value is, right? Or I can get its value from the histogram array. And then what I do is I would need to compute the area.
Yeah.
Right? So at this point, I have already incremented I, right? In the previous iteration. In the previous iteration, I had already incremented I. So the way I come here is by checking that, hey, actually the histogram value at I is greater than my topmost value, right?
Yeah.
So the I that is the index of cur max will be actually one less than that. Right? It'll be I minus 1. So in order for me to compute the area, let me just call it area equals, I would need the I would need the height, or basically the value at cur max. So I'll say hist cur max times I would say whatever I is minus 1, right? whatever I is minus 1, so that would give me the index of this guy right there, if this is the current max, basically. And then I would want to go all the way to my previous number in the stack, right? So I would say minus stack dot peak, right?
What if there are no elements in stack?
So what if if there are no elements in the stack, then I would just not have this one, right? I would just have I minus 1. So in this case, let me actually put that in. I would say times stack dot is empty if stack is empty, or let me call this, if stack is empty, then we would say that it should be times I minus 1.
Yeah, because you want to go all the way.
Right, we don't want to go all the way. But if there is something, then we'll say I minus 1 minus stack dot peak. Right?
Yeah.
Perfect. So now we'll have the area. Then we'll just do a comparison that if area is greater than max, max equals area, right?
Yeah.
So this actually concludes this while loop. So we'll go through all of them. By the end, we will have some bars left that we haven't computed the area for. So we'll have to pop, all of those. So let's do another while loop. So we'll say while.
So this is for the remaining bars that we have in our stack, right?
Exactly.
Yeah.
So I'll basically say while stack is not empty, keep popping. So I'll say while stack dot, let's say while stack dot peak, while there's something in the stack. Keep doing this. So what do? We actually perform the same logic. We'll say cur max equals stack dot pop, right? We'll say area equals the same computation, hist cur max times the ternary operator stack dot is empty I minus 1 else I minus 1 minus stack dot peak, right?
Yeah.
And then the same conditional. So if area is greater than max, max equals area. And that concludes the while loop and also concludes our function.
Looks good. So don't you think you should return the max value?
Oh yeah, we should also return the max value at the end. We didn't do all this work for nothing. So I'll say return max. And we're done.
Better now.
Thanks for watching, guys. If you like this video, let me know by hitting the like button below. And next week, I'm actually giving you the option of choosing which problem I should cover. So the first one is, should I cover n queens, where you need to place n queens or n number of queens on a chessboard such that none of the queens are attacking each other. Or the second one is 0-1 knapsack. It's actually a very popular problem with dynamic programming. So let me know in the comments below which one you would like me to cover, and I'll see you next week.